Hi everyone, I'm Andrew and welcome to Sarawak. My wife asked me to remove the clothesline from above the area that I do my dirty and dusty wood turning and move it to somewhere a little cleaner, which seemed a perfectly reasonable request. But as I was moving it, I discovered that the end caps that keep the wasps and bees from building nests inside the tubes had degraded in the sunlight and were completely falling apart. So this video is about why every home handyman and DIY guy needs to have their own, or at least access to, a 3D printer. I've opened up Fusion 360 to do the design in. It's a great program and free to use for hobbyists, and I use it quite a lot for repair projects like this one. I measured the outside of the clothesline bar to build a base for making the end caps. I didn't try to measure the original end caps as they were far too degraded to provide an accurate number. The large tube was 28mm and the smaller one was 8mm, and they were 28mm apart, connected by 2mm thick flat plate. I started out by sketching the design of the bar so that I would have the internal design of the end caps. I didn't leave any clearance as I wanted them to be a tight fit and not to come off without a fight. Once I had the initial sketch of the bar, it was simply a matter of inflating the outside of the design to give the design walls that could be extruded upwards. I decided to increase the outside diameter of the circles by 3mm, which will give the part a 1.5mm wall thickness. It could be less, as the part doesn't need to bear any stress and doesn't need to be strong, but this just looked like a good size. At this point I realized as I tried to extrude the walls that I hadn't extended the first rectangle far enough into the circle to allow for it to intersect with the walls of the circle, meaning that it would cause an artifact in the extrusion. So I'm just expanding the initial size of the rectangle a bit more to make it cut out that artifact. Extruding the base and the walls gives me a cap that could fit over the bar well enough, but would look pretty basic and simple. So now is the time to add chamfers to make it look a bit more professional. And remember that any chamfer that you apply only to the outside of a design will decrease the wall thickness in that area. So if you do need the wall thickness, make sure that you put the chamfer on the inside of the design as well, and that will help you to keep the thickness if you need it. I also ended up adding a chamfer to the top to make it just a bit easier to slide the end cap onto the bar. Having finished the model, it was time to send it off to the 3D printer. This whole project for the 8 end caps took 15 minutes of modeling time and a little over 4 hours and 15 minutes of printing time. So the whole project to measure, model and produce these end caps took about 4.5 hours, which is pretty good given that there's no way to actually purchase these end caps anywhere else where I am. The cost for these 8 end caps came up at 4.5 ringgit, which at the current conversion rate is $1 and change, and they're printed out of a bio-PT filament, which is a bioplastic, so there's no environmental impact with printing these out at all, other than electricity costs. So here's the new ones up against the original. You'll be able to see what they look like. They're not too bad of a match. I think I did all right. So they look about right. So let's see how it fits. There we go. Look at that. It's like it was made to do it. Alright, I'll put the rest of these on. These fit really well, and for what was 15 minutes of work and 4.5 hours of waiting, it's really quite easy to fix this sort of stuff if you have a 3D printer on hand. I have a heap of 3D printed parts scattered around my house. Some of them have been used to repair broken household items, some of them have been used to repair broken children's toys, and some of them have just been used to provide a function all of their own. Broken household items that were once considered beyond repair can be brought back to life through the use of 3D printing. As long as you can model the part, you can print one out into a fairly high standard of quality to replace whatever is broken in your item. Now, originally, if something broke in a part where the company didn't sell it, you had to throw it away. There was nothing you could do. Unless you could scavenge the part from somewhere else, that was it. Nowadays, with a 3D printer, you can model it, replace it, and have the item working again in under a few hours, depending on how big the piece is. We had a stick blender where one of the drive gears from the reduction gear set broke after about 5 years. Normally this would mean that you would have to throw the whole attachment away because there was no way to repair the gear, and the company wouldn't sell just that piece to replace it. You had to buy a whole new blender set. But I was able to open up the part, pull out the gear, model it, replace it after printing it out, all in less than a few hours. So throwaway item to back to fully working in under 2 hours. That's pretty good. As a woodworker, one of the things that I use my 3D printer for is adapters. A lot of adapters. This is the adapter for the dust port from my disc sander. It allows it to connect directly to the Bosch Click and Clean ecosystem, meaning that I don't have to sticky tape an adapter to the end of a port anymore. I just plug it straight in, and that's pretty useful. Other things like this is part of the dust management system for my lathe. This is just a simple dust catcher for sanding dust. I've also used it for jigs. I've used it to make design templates, router templates, and lots of other things. I've even used it to make a 0.4mm thick shim for a door. Now, I'm pretty good with a saw, but I'd never be able to cut a 0.4mm thick piece of wood in order to bolster that door back up to the normal height. So it's good to be able to do that sort of thing. And again, if I ever need to increase it, I can just print out another one in a matter of minutes. Now, not everybody's going to have access to a 3D printer, and that's fine because not everybody needs one. But your local library or your makerspace nearby is surely going to have a 3D printer somewhere. And chances are they'll let you use it for either a small fee or for just the cost of the filament that goes into it to make the item. And that will allow you to print out the small things you need, even without having a printer. But if you do want to buy one, and that's fair enough, I like tools and toys, there are budget 3D printers available for less than $200 US. So it's certainly not going to break the budget, particularly if you can use it to fix things around the house. It may even save you money. Thanks for watching, and don't forget to like, subscribe, or leave a comment if you liked the video. And I'll catch you in the next one. Have fun making things, guys.